Today's problem, next greater element in circular array, difficulty is medium. Given a circular array, the task is to determine the next greater element, NGE, for each element in the array. The next greater element of an array, I, is the first element that is greater than array I when traversing circularly. If no such element exists, return 1 for that position. Note, since the array is circular, after reaching the last element, the search continues from the beginning until we have looked at all elements once. All right, well, we'll come back and look at some of these examples. Array size will be somewhere between 1 and 10 to the 5th, 100,000. The array elements will be somewhere between 0 and 10 to the 6th, 1 million. Expected complexities, O of n, auxiliary space, O of n, because we're going to use a stack. Okay. Well, next greater element. So here's a problem where, it would be nice to have an easy way to do look-aheads, okay? And when you encounter a problem where it would be nice to be able to do look-aheads, you should at least consider, what if I processed the data backwards, so to speak? So in this array here, 1, 1, 3, 2, 4, what if I processed it like 4, 2, 3, 1? Okay. Now this, we can see how this works even without a circular array because of the data. But let me see if we can work through this. So actually what we started out doing was something like this. So we have a four element array input, and so we'll have a 4-element output array. Let's just put it up here. And we initialize it with -1s. All right. I'm going to simplify this a little bit in the way that I'm doing it here. This will be our stack. Okay, and I'll start at the end here, 4. Now there's nothing on the stack here. In which case we can't. There's nothing here there's nothing here greater than 4. So all we can do is push the 4 and move on to the next number. The next number is a 2. Now we look at the stack here and there's a 4. Well, the 4 is greater than the 2, and since we're moving backwards, that does mean that 4 would be the next greatest element for 2. So in the array here we can change that to a 4 and then push the 2 on the stack. If we go to the next number, it's a 3. Now the 3 is greater than the 2. We don't want that. So smaller numbers get popped, right? Oh, here's a 4. Okay, so now that's a bigger number, so we can put a 4 in here and then push the 3 on the stack, and we'll go to the next number, which is a 1. Come over here, 3 is bigger than 1, and so what that means is that we can replace that number on the stack. Okay, 3, 4, 4, -1. That is the correct answer. Let me get rid of that. Okay, now this one down here, this one is harder, because this one we need a circular traversal, because these 1s here, we do need to find bigger numbers than the 1. There are bigger numbers than the 1 available. So what that means is we go through the stack once to, I'm sorry, not the stack. We go through the array once to set up the stack, and then we go through it again, and we should get everything that we need. So let's take a look at how that would work. Actually, now that I'm looking at this, this is not really readable like that. All right. So back to the pen. So int n, okay, res, that's the result array. A new int n, and we have a stack, and we're going to put -1s into the array. And let's just put it right here by the output array. -1, -1, -1, -1, and -1. All right, so where can we put the stack? We'll put the stack here. All right, for I equals, all right, we have to go through this twice. So we are starting with I at 2 times n minus 1. What is n here? N is 5. So we are starting with I equals 9, right? I should probably write that down to keep track of it. I starts at 9. Now, that's not going to be of much use. I mean, it's useful as a counter. It's not going to be much use as an array index. So we're going to mod it when we use it as an array index. All right, int current num equals nums 9 mod 5. That is 4. So the array current number at index 4 is a 1. Right? Let's put that here to 1. While the stack is not empty. No, the stack is empty. And this one also requires that the stack be empty. So forget that. We'll just push the index 9 mod 5. All right, we're pushing the index. When I did the example, I pushed the actual numbers, but we are pushing the index. Okay, index is 4. All right, back up here. This is now 8. 8 mod 5 is 3. The number at 3, current num, also 1, while not stack empty. When the stack is not empty now, and nums stack peak. So the nums at stack peak is 4. Nums at 4 is 1. Is that less than or equal to the current number? Yes. In that case, pop it. Okay, so we'll do that. Pop it. Down here, now the stack is empty again, so we can't do this. Stack push. We're going to push the index, and the index is 3. Why do we pop the 4 and push the 3? Because we're looking for the next greatest element. Okay, and we're going to hit element 3 before we hit element 4, even if they're equal. What we want is element 3. Okay, let's update the loop. It's now 7. 7 mod 5 is 2. And the number, current number, is 3. Okay. Is the stack empty? No. Is the number at stack peak 3? Is that less than 3? Yeah. Nums at 3 is 1, which is less than 3. So we got to pop it. Okay. It's gone. Okay, that's done, and the stack is empty again. So we are going to push 7 mod 5, which is 2. Okay, push the 2. Back up to the top here. This is now 6. 6 mod 5 is 1. Current num will be 2. Is the stack empty? No. Is nums at stack peak less than or equal to current num? So is 3 less than or equal to 2? No. So we're not popping anything. Is I less than n? Okay. Well, at this point, we can't really, we haven't seen all the numbers yet. We can't really say, I mean, we can't make a decision about the next greatest element until we get to processing the numbers in the real array. The first pass is just to set up the stack. So that's what the I less than n means. It means, are we on the first pass or the second pass? And I is 6. It's not less than n. So we are on the first pass. So we're not going to do this. All we're going to do is push 6 mod 5. That's 1. Okay. This goes to 5. 5 mod 5 is 0. Current num is 0. Stack is empty? No. Is nums at stack peak, which is the number is going to be 2. Is it less than or equal to the current num? No. Is I less than or equal to, I'm sorry, is I less than n? Is 5 less than 5? No. So we'll push I mod n, which is 0. Okay, good. So now we have the stack set up so that we can use it as a circular array. All right, we're back up to the top here, and I'm kind of running out of room, so I is actually going to go to 4, but let me get rid of some of this and just put a 4. Okay, 4. And actually, let me start over again on this as well. It's getting a little messy. 4. Current nums. Current nums. I mod it. Well, we don't have to mod it anymore. Nums at 4 is 1. While the stack is not empty, and nums at stack peak, okay, stack peak is 0, and that number is a 0. Is that less than or equal to 1? It is. So we are going to pop it. Okay. Now we're still in the while loop. Now nums at stack peak. Nums at 1 is 2. Is that less than or equal to 1? No. Is I less than n? Yes. Stack is not empty, so res at I, which is 4, is going to be nums at stack peak. That's a 1. We go up here, it's a 2. So this number at index 4 becomes a 2. That was the point of going through the array once, is that we're able to set up this ability to look at things in a circular fashion. So even though that 1 is at the end of the array, we can still wrap around and see the 2. Okay? And stack push I, that is a 4. Okay? This goes to 3. Current nums at 3 is also a 1. Is the stack empty? No. Is nums at stack peak less than or equal to the current num? Yeah, they're both 1. So we're going to pop it. Okay? Still in the while loop. Is nums at stack peak, which is 2, is that less than or equal to 1? No. I is less than n, stack is not empty. Res I is nums at stack peak, which is index 1, and that is a 2. So this number here becomes 2. Okay, again, it allows us to see around the corner and back to the front of the array. All right, this goes to 2. Current nums at 2 is 3. Okay. Is the stack empty? No. Is nums at stack peak less than or equal to current number? Yes. It's a 2. So, we got to we have to pop it. Okay. Still in the while loop. Nums at stack peak. Nums at 2 is 3. Is that less than or equal to 3? Yes. We got to pop it. Right? Well, the stack is not empty anymore. So we're out of the while loop. We can't get into the if here because the stack is empty. So the only thing we can do is push that number on the stack, the index, and that is a 2. That's going to work out fine because this number is supposed to be -1 anyway. That's the biggest number in the array. Okay, back up here. This goes to 1. Current nums at 1 is 2. Stack is not empty. Nums at stack peak. Is that at stack peak? So that's a 3. Is 3 less than or equal to 2? No. So no popping. Down here, stack is not empty. Res is equal to nums at stack peak, and that is a 3. So this number at index 1 becomes 3. Okay? And we push I, which is 1. All right, last time, 0. This is now at 0. Current num, index at 0 is 0. Is the stack empty? No. Is nums at stack peak, which is 2. Well, stack peak is 1, and the num is 2. Is it less than or equal to 0? No. So no popping. Okay, that's true. That is true. So res at I becomes nums at stack peak. Stack peak is 1, nums at stack peak is 2, and so that first number at index is 0 becomes 2. And that gives us the right answer, right? 2, 3, -1, 2, and 2. So we can do it with a stack. I mean, if it's not a circular array, then you can do it the same way, next greatest element, with just one pass through the array and a stack. If it's a circular array, you need 2 passes through the array. The first pass is just to set up the look-ahead numbers for some of these numbers, if needed at the end of the array. Okay, now before we run this, I just realized, through this whole thing, array, and now I look at this and say, oh, it's not. We're not supposed to return an array. We're supposed to return an array list of integers. So maybe we can do some surgery on this. So this is what needs to change. Is this needs to be a list of integers, and this needs to be a new array list. All right, now where are we using res here? All right, so we'll do res dot add add -1. Where else are we using res? Res at I. Okay, so res, we want to add at an index, which would be I, and oh yeah, we're doing this Oh, I'm not sure that's going to work because we're doing it backwards. No, that'll still work because we initialized it. So no, that'll still work. Okay, erase. No, not there. Array stack peak. All right, but that's what we want to do. Except not an add. It needs to be a set. All right. Let's try it. Return res. The list integer can't be converted to array list integer. Okay. No problem. Try it now. All right, that worked. Let's try and run it. All right, good. Let's see. So, yeah, feel free to like the video, subscribe to the channel, and see you next time.